A sun tracking system. Now, what is a sun tracking system? Is basically a system which has a source component, which is your sun or solar energy, a panel, solar panel, which will absorb this energy and convert it into electrical voltage or current. So the main idea behind it is, nowadays we have a fixed panel system. So the panel is fixed at optimum angle where we can get the maximum energy, and it does not rotate. So daily your sun travels from, let's say, east to west, and then there is also a component called Uttarayan and Dakshinayan, where the sun moves every 6 months towards left or right of its original position, and that changes the total day duration. That we know that 21st December and 21st June, smallest and biggest day. I'm not sure, I guess it's 22nd December, I guess, and 21st June. So that is because the sun will follow the biggest path. If this is the actual path, it will have some angle like this, and it will come back to the same position. It's going away, 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 and then coming back, coming back, coming back, and that's why the day elongates. And the smallest day, it will travel exactly at 0 degree. So this angle we call it as theta. Then theta always varies from 0 to 180, but if we call the other angle as phi, so that phi will also have a variation. At max, the phi could go between very small values, let's say plus minus 90 degrees. It cannot exceed that. So this is how the sun is moving. Then a question arises, why the plate is fixed. There are many algorithms like MPPT, maximum power point tracking, which is very popular, because with the fixed plate your voltage current characteristics look something like this, and if you plot them in a PV curve, there will be a maximum power point. For this corresponding MPPT, there would be a maximum voltage at power point and maximum current. So this is your I max. That same could be the same power at the max, but the power is maximum, which is P equal to V into I. So this is P max point, and if you track this point, that means your plate is connected to the battery during this maximum power point, then the optimum charging will take place, and that may not be the maximum voltage your panel can reach or maximum current at which your panel is, or it can be also. So we always try to track P max, and that's why with the fixed system at, let's say, theta, you can achieve certain amount of power, let's say 100 watt. Now assume a situation, if I connect the axis and rotate this according to the sun. So when sun is there, your panel is facing right, tangential or perpendicular to it. If your sun is here, your panel has changed the direction, again perpendicular. If your sun is here, your panel again changes. If sun is here, your panel changes. And you can assume the amount of power will go high as 40 watts, 140 watts basically extra. And this is just the new numbers that we have calculated, and this is a open loop system. Now open loop sun tracking system, as you know, the sun will follow an equation with respect to the earth's latitude longitude. At any given time you can exactly predict where the sun will be, and that's what we have implemented through our system. So we always follow where the sun is. We exactly know where it should be, and it is always there. So this requires very complex formulas for tracking down the sun's location, and you can easily Google it for those formulas, put them into your microcontroller, and that take care of your theta. Now what is special about our system is we have developed a 2-axis open loop system. So 2-axis open loop system basically follows the sun not only with respect to theta, that is 0 to 180 degree daily, but also its Uttara and Dakshinayan motion, that is phi variation. So your panel, if you see motion of axis, this is the first motion and this is the second motion. So it can go something like this as well as this. And this is achieved through a stepper motors. Obviously I know the duration may not exceed 180 degrees, so you can go for servo also, because you know whenever sun rises and it sets, it cannot have exact 180 degree angle. This is 180. It will be always less than 180 because of some mountains or whatever plane of horizon through which we can see the sun. Now this is the first approach, open loop 2-axis sun tracking system. Now the next approach will be to make it a closed loop. Now there could be a cloud in between a sun and a plate. So first approach assumes that sun always, when your plate is perpendicular to the sun, irrespective of how many whatever clouds plane is in between there, you can have a plane also in between, but daily if you follow the sun location, you will get a maximum power. The second approach is called closed loop. Now in closed loop sun tracking system, what is the advantage or the disadvantage we will briefly discuss. Now in closed loop sun tracking, we always try to follow maximum light intensity. That is the difference. In open loop we follow the sun's location. This time we try to follow the maximum light intensity. Now here what happens, if you have a plate, if you have a cloud, let's say a very dark cloud, and this is your sun, and you can see the light rays are maximum at this position and may not be, most of them were absorbed and very less light is coming through the cloud, and again there is a maximum intensity. So this is basically shadow. Now very unusual circumstances, this cloud is not moving at all and it's exactly in front of the sun, or there is a solar eclipse kind of thing where moon is in between sun and earth. So in such cases only your panel will not be focusing towards sun, because the maximum intensity is somewhere else. So it is better to flip the panel at this location rather than keeping it following the sun. And that's what we achieved through a closed loop system, where we have a plane. Now this plane sheet, there are two LDRs, LDR1 and LDR2. So when you are exactly looking at the maximum intensity and perpendicular to the sun, both the LDRs will receive the same component of photons. Now a slight deviation from this angle, there will be definite shadow created, and this shadow created will fall on one of the LDRs. As soon as you get a shadow on the LDR, you try to move your panel in opposite direction so that that shadow disappears and you are looking perpendicular to the sun. And that's how your plate should move. As well as it could be a position something like this, where both our LDRs having shadow, and then the tracking is not possible. So you have to club it with open loop. So we know that the panel is looking towards sun perpendicular.